are you, my friends? This is another pre-calculus challenging question. Finding the domain of this logarithmic function, f of x equals log base 7 of absolute value 7 minus x, all divided by x squared plus 7x minus 60. For more pre-calculus challenging questions, you can see the playlist written here, please. Now, this is the function which is given. I would like to define the domain first. For the people who don't know what is a domain. Domain is the set of all real numbers for which the expression is defined. Simply, it's the values of the x that have images. In other words, we can say set of inputs. So when we say find the domain, that means we have to look for all values of the x that we can replace inside the function here. This one, and this one. So that we have a defined value for y. So every x that has an image, x is in the domain. If x has no image, no y value, image means y value. If x has no y value, then x is not in the domain. Now, to find the domain of any logarithmic function like this one here, we must take the argument. This is the argument here. All of this in the bracket is the argument, regardless of the base. The base can be 7 or 8 or 9 or 10 or half. The base should be positive and not equal to 1, not negative for sure. So the argument should be greater than 0. Now let's continue here. So I take the argument, just quickly please here. This is the argument, absolute value 7 minus x divided by x squared plus 7x minus 60 greater than 0. Now there is something in algebra here you have to know about absolute value. Just to remind you, absolute value of a minus b, the same as absolute value of b minus a. If there is no absolute value, these are not equal, remember. So absolute value of 7 minus x, the same as absolute value of x minus 7. So in this question, if you have another question with absolute value of x minus 7, it will be the same function, same graph, same domain, same everything. Now, let's continue now. We need to find the values of the x. So we have to solve this. Now, in algebra, we call this rational inequality because that's a fraction here that needs to be solved. So you can review the algebra course, lecture 25. You will have many questions there about polynomial and rational inequality. So let's solve this now to find the values of the x, which is the domain. Also, we have to know, since this is positive here, absolute value of 7 minus x is positive, which is greater than 0. But remember, x cannot be 7. If you put here 7, that will make this number 0, and 0 cannot be greater than 0. So remember, to find the values of the x, the domain, x cannot be 7. So you have to put this condition at the beginning. That's why we have this challenging question. Also, there is a little remark here. At the end of this video, I will show you what happens if there is no absolute value completely. So if we have here a normal bracket, the answer will change. So if there is no absolute value, that means 7 minus x and x minus 7 are not the same. Each one will give you different domain. Let's continue now with the absolute value, and I will do this remark at the end. So we go back to the argument here. Remember, this is the argument, and we need to factor the denominator. So this is x squared plus 7x minus 60. just simple factoring, x plus 12, x minus 5. If you multiply here, you will get x squared plus 7x minus 60. So from the last slide, we have this argument greater than 0. We have discussed already the absolute value of 7 minus x. And the only thing we have to know is x cannot be 7. Now here in the denominator, I look at each factor and then I ask, what number will make each factor 0? I will use that in the table of signs here. So this number here will be minus 12, so we call it a 0 of this factor, and here we call it the 0 will be 5. So I can put here 5 and then minus 12. So I'm trying to build the table of signs, which will be in algebra course, lecture number 25. If you want to go and see it, more questions are there. So I put here the factors, x plus 12, x minus 5. Then what do? I just pick up, I choose a number between minus infinity and minus 12. Any number, I can choose minus 20. If I put x there, that will be negative. And I put x, the same number here, minus. You can choose a minus 100, minus 50, any number less than minus 12. Now between minus 12 and 5, I can choose a 0 or 1 or minus 1. So I put it here in the x, I will get the quantity here is plus. If I choose here, like 0, if I put here 0, it will be minus. If I choose any number greater than 5 until infinity, maybe 100, it will give you plus and plus. Now I multiply minus and minus, it will give me plus. That's the result here in the circle. Plus and minus, it will be minus. Plus times plus will be plus. So I choose the greater than 0. Greater than 0 means the plus. So from the table, this table here, I choose the x values. How do I choose them? The plus, which means all the values of the x from minus infinity until minus 12 here. You see that? That will give me plus. The product will give me plus. Union, all these numbers from 5 until plus infinity. Now, this is not the answer for the domain. This is from the table. But remember, x cannot be 7. So I check, is 7 inside here? Yes, it's here somewhere. So I have to take it out. So the final domain of the given function f will be minus infinity to minus 12, union 5 to 7, union 7 to infinity, and there is open here at 7. That means 7 is not included, 5 is not included, minus 12 is not included also. Now, what will happen if we have no absolute value? So I will call this function capital T, T of x, log base 7 of 7 minus x divided by x squared plus 7x minus 60. Remember, the argument should be always positive. So now I take this factor here, 7 minus x. I include that in the zeros here. So 7 is one of the zeros. It will make it 0. Here 5, it will make it 0. And here minus 12. And I also included 7 minus x. You see, there is no absolute value. So it is not always positive. So when I choose here a test point, let's say minus 20, put here 7 minus 20 becomes plus. If I choose here 0, it is plus until I choose a number greater than 7. Let's choose 50. 7 minus 50, that will be minus here. So the table will change. Now, if I multiply all these, multiply or divide, it's the same. See, when we multiply the signs or divide them, that will be plus. Here it will be minus. Here it will be the result plus, and here will be minus because we have minus and 2 pluses. Now, also in the domain, I choose the greater than 0 here. See, I choose the plus. So from minus infinity to minus 12, union, where is the plus? From 5 to 7. That will be the domain of the above function, capital T. Now, what will happen if I have x minus 7? It will make a little change. Let's consider the function h of x, log base 7 of x minus 7 divided by this. I take the argument greater than 0 very quickly. I take all the zeros, minus 12, 5, and 7. I make the nice table here. See, now if I choose a number between minus infinity and minus 12, which is like minus 20, see, minus 20 minus 7 becomes minus. If I choose here 0, 0 minus 7 becomes minus. 5 to 7, I can choose 6. 6 minus 7 becomes minus. Any number greater than 7, let's say 50. 50 minus 7, that will be plus. So when you multiply now 3 minuses, it becomes minus, and this one plus, and this one minus, and this one plus. So I choose now the greater than 0 for the domain. So the domain of the above function h, this function here, minus 12 to 5, open for sure, union 7 to infinity. Now, to make things easy on you, I put here for you the summary. Just enjoy here by looking. This is the function f. That was the beginning, the question, the original question. The domain is the values of the x. That is the domain. You can see the details again. If you change the absolute value here, only 7 minus x, domain will change. These are the values of the x we can use for graphing. And then if this is x minus 7, this is another function also, and the domain will be different. Now, for more logarithmic functions and graphs and other properties, you can visit, please, the playlists, either Pre-Calculus Old Exams Questions, Logarithmic Function, or Pre-Calculus Course, Lectures 4 and 5. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I wish I can see you in another video with another pre-calculus challenging question. Thank you for listening, guys.